Stars, planets, black holes, galaxies, and the entire universe, this process of existence, which began approximately 13.8 billion years ago, when will it end? How will it end? And why will it end? As humanity, will we ever be able to witness this? Or could we, as a civilization, do something to prevent the death of the universe? Today, together with you, we will take a detailed look at theories about the past of our universe, its future, and how it might eventually die. Before we begin the video, if you're not subscribed to the channel, don't forget to subscribe, like the video, and please share your thoughts in the comments. Now, if you're ready, let's set off on a journey from the earliest moments of our universe through today and onward toward its eventual death. When we try to talk about the past of the universe, the very first thing we realize is that the concept of the past itself emerged together with the universe. In other words, the question that comes to many people's minds, but is often abandoned due to the lack of a clear answer, what was there before the Big Bang, unknowingly takes us to a place where even time and perhaps even nothingness did not exist. I say even nothingness because for nothingness to exist, there must first be something, at least as far as we currently know. Before the universe formed, there was nothing. Anyway, the answers given to this question are generally unsatisfying because the human mind did not evolve to imagine a timeless state. We understand everything through a sequence of before and after the universe, before and after a war, before and after a discovery. Yet at the beginning of the universe, there wasn't even a clock to create such a sequence. According to modern cosmology, time, space, and matter are not independent things. They are different faces of a single fabric, what many people know as space-time. The event we call the Big Bang was not an explosion that occurred within space. It was space itself beginning to expand in all directions at once. This distinction is extremely important because if there is no space, there is no place for anything to explode into. As a result, the birth of the universe was not a bang in the conventional sense, but rather the moment when existence itself stepped onto the stage. At this point, science leads us both into a dead end and toward a deeply astonishing truth. The equations that describe the beginning of the universe lose their meaning beyond a certain point. When we trace time backward using general relativity, we are led to a point of infinite density, a singularity. But a singularity is not a physical object. On the contrary, it is a boundary where the laws of physics break down. In other words, what we call the beginning is a threshold where science ends and questions remain unanswered. And it is precisely at such points that the theories many of you have heard about come into play. The Big Bang is an observationally very powerful model. It clearly shows that the universe is expanding and that it was hotter and denser in the past. The cosmic microwave background radiation proves that this hot beginning is still echoing throughout every corner of the universe today. However, this only tells us about the early period of the universe, not its absolute beginning. In fact, many scientists who propose these kinds of theories are well aware of this limitation, and because of it, they attempt to speculate about what might have existed before the Big Bang. Some suggest that there were two atoms and that a collision or event involving them led to the birth of the universe. Others argue that the universe formed from the remnants of another universe's death. In other words, there are so many different views on this subject that even when the main idea is similar, the details branch off in different directions. Because of this, we constantly encounter different theories and different possibilities regarding the origin of everything. One of these different scenarios is the quantum vacuum. What we casually call empty space in everyday life is not actually empty at all. According to quantum physics, even empty space is constantly fluctuating. Virtual particles appear and then disappear. Energy never ever truly stays at zero. This idea suggests that the universe may have emerged from a kind of quantum fluctuation. In other words, the universe may not have originated from absolute nothingness, but rather from an unstable quantum vacuum. In this case, even what we think of as nothingness is actually filled with potential. This line of thought naturally leads us to inflation theory. If you haven't heard of inflation before, it proposes that immediately after the birth of the universe, space expanded at an unimaginable speed. This expansion was so extreme that a region smaller than a proton grew to the size of the observable universe in a tiny fraction of a second. Inflation theory is remarkably successful at explaining why the universe looks nearly the same in every direction, why it appears geometrically flat, and why it contains specific density fluctuations. In fact, this theory also leads us toward the idea of the multiverse. In short, according to this view, our universe may be just one of many universes, but regardless of whether our universe is a single system or part of a multiverse, it was born and it evolved. The real question is, will it truly die one day? The first thing that reminded us of this idea of cosmic death was the discovery that the universe is expanding. When this expansion was first observed, it was thought that it would gradually slow down and eventually stop. The logic behind this idea was actually very simple. Matter has mass, mass creates gravity, and gravity should oppose expansion. The universe may have expanded rapidly at first, but over time this expansion should have been slowed down. Some scientists even believed that the universe would eventually stop expanding and collapse back in on itself, an event known as the Big Crunch. For many years, this was considered the most reasonable final scenario. However, as years passed, technology advanced, and our knowledge of the universe increased, many new theories were proposed, some less convincing, others more compelling. In the late 1990s, observations revealed something completely unexpected. The expansion of the universe was not slowing down, it was accelerating. Following this discovery, the concept of dark energy, which we have previously covered in one of our documentaries, was introduced. Dark energy makes up approximately 70% of the total energy content of the universe. In other words, the majority of the universe consists of something we do not fully understand and cannot directly observe. Dark energy does not interact with light, does not behave like matter, and does not resemble any known force. Yet its effect is clear. It stretches space, pushes galaxies away from one another, and continuously accelerates cosmic expansion. Thanks to this discovery, scientists proposed a new scenario for the death of the universe. According to this scenario, the accelerating expansion driven by dark energy will pull galaxies apart from each other, stars away from stars, planets away from planets, disconnecting everything from what it is gravitationally bound to. Eventually, this expansion will become so extreme that the formation of new galaxies, new stars, and new planets will become impossible. Matter will be too far apart to interact. After millions and then billions of years, all existing systems will exhaust their lifespans and collapse. And since no new systems can form, the universe will effectively be dead. However, we still do not know how long dark energy will maintain its strength. Perhaps over time it will weaken, causing the expansion of the universe to slow down, meaning this scenario may never actually occur. Some scientists even suggest that such a collapse could mark the beginning of a new universe. In this view, the universe may not be something that is born, lives, and dies only once. It could be a cyclical structure, born, evolving, collapsing, and then being reborn. At this point, many of you may find it difficult to follow, but this idea has led astronomers to focus on black holes. Black holes are structures that exist at the extreme limits of space and time. For an observer who crosses a black hole's event horizon, space and time fundamentally change their meaning. To an outside observer, falling matter never appears to fully cross the event horizon, but for the object falling in, there is no possible escape. Based on this paradox, some scientists have asked a profound question: if reality changes depending on the observer, could the same be true for the universe itself? Some theories take this idea even further, suggesting that the entire universe may possess a kind of event horizon. We can never see the boundaries of the observable universe because light from beyond them has not yet reached us. As a result, we do not know what lies beyond that boundary, whether a boundary truly exists at all, or what kind of physical laws might govern it. This is where the idea of the holographic universe comes into play. According to this concept, all information in the universe may be encoded on a two-dimensional surface, and the three-dimensional reality we experience could be a projection of this more fundamental two-dimensional information. This is precisely why black holes play such a central role in our discussion of the universe. The holographic idea emerges directly from black hole physics. The notion that information falling into a black hole should never be lost may apply to the universe as a whole. So, one way or another, what will happen after the universe ceases to exist? Will a new universe emerge, or will fragments of our universe remain? Could these remnants become the first building blocks of a new system? To answer these questions, we need to dive deeply into the details and carefully examine existing research. The first thing I want to mention is a common mistake we all make when thinking about the end of the universe. No matter how knowledgeable someone is, whenever I talk to people about this topic, most imagine that everything will end all at once, that everything will be swallowed by darkness, and that an absolute nothingness, where even nothing no longer exists, will take over. However, the laws of physics suggest something very different. The death of the universe is highly unlikely to be a dramatic closing scene. Instead, it will most likely be a very long, very quiet, and very slow process of dissolution. When stars burn out, when galaxies disperse, and even when atoms break apart, the universe will not completely disappear. In its final stages, what will most likely remain are only fundamental particles and extremely low energy radiation. Time will still continue to flow, but there will be no events left by which this flow can be detected or measured. At this point, the concept of entropy comes into play. When entropy reaches its maximum, the system will still exist, but nothing will happen. This state is physically possible but functionally dead, and it is known as heat death. The universe ceases to be a dynamic structure and becomes a frozen background. And now we arrive at the detailed part I mentioned earlier, quantum mechanics. Quantum mechanics never allows absolute stillness. Even at the lowest possible energy levels, there are fluctuations. So even if the universe appears to be completely dead, there is still microscopic motion taking place. In other words, even the death of our universe is not true silence. This naturally leads to an important question. If quantum mechanics does not allow absolute stillness, and if tiny fluctuations continue to exist, could these fluctuations give rise to a new system? According to some theories, even in the universe's final state, quantum fluctuations could serve as the seeds of a new beginning. In this sense, the universe could be reborn from its own ashes. This idea forms the foundation of cyclic universe models. The universe expands, cools, disperses, and then, even if the probability is extremely small, a new Big Bang-like event may occur. But then another question arises: what about time? If a new universe forms, does time start from zero again, or does it continue from where it left off? And if life similar to ours were to arise in this new universe and somehow discover the existence of our universe, what would time mean to them? At this point, the questions reach levels that the human mind is currently incapable of fully comprehending. This is because every technological advancement humanity has made since the discovery of fire has been built step by step upon the previous one. After discovering fire, we could not immediately build computers. Without learning how to process metals, we could not develop complex structures. For this reason, our current level of knowledge and technology is simply not sufficient to provide definitive answers to these questions. Additionally, many people believe that information is completely lost once it falls into a black hole. However, Hawking radiation tells us that black holes do not destroy information. Instead, they release it back into the universe extremely slowly. This implies that no information in the universe is ever truly lost. Because of this, if a new universe were to form, intelligent life with sufficiently advanced technology and knowledge might be able to learn about the previous universe, our universe. Finally, some physicists believe there may be a deep symmetry between the final state of the universe and its initial state. In this view, the death of the universe could be the mirror image of its birth. The Big Bang and heat death may stand at opposite ends of time, yet be mathematically connected states. So there you have it, my friends. We are part of a universe that has existed for nearly 14 billion years. To some, humanity is the most important part of the universe. To others, we are no different from a grain of sand in a vast cosmic desert. Personally, I'm very curious about your thoughts on this because I believe the ideas of people who research and think deeply about these topics are far more valuable than those of people who have adapted entirely to everyday life without curiosity. If you're watching this video, it means you're just as fascinated by space and the universe as I am. So what do you think? Will our universe one day come to an end? If so, how will it end, and will a new system emerge afterward? I want you to share your detailed thoughts on all of these questions. Believe me, I will read every single comment carefully. That's all from me for today. Until we meet again in the next video, don't forget to subscribe to the channel, like the video, and take good care of yourselves. Goodbye.